In gravimetric analysis, what is the primary technique used to determine the amount of an analyte in a sample based on the mass of a solid precipitate formed? A. Titration. B. Colorimetry. C. Weight measurement. D. Chromatography. The correct answer is C. Gravimetric analysis relies on the measurement of the mass of a precipitate to determine the amount of the analyte present in a sample. Which method involves the addition of a second reagent to the sample solution for the purpose of co-precipitating the analyte and helping to improve the purity of the precipitate in gravimetric analysis? A. Back titration. B. Complexometric titration. C. Co-precipitation. D. Redox titration. The correct answer is C. Co-precipitation is a method used in gravimetric analysis to enhance the purity of the precipitate by co-precipitating the analyte with a second reagent. Post-precipitation is a technique used in gravimetric analysis to further purify the precipitate by performing which of the following actions? A. Filtering. B. Drying. C. Washing. D. Weighing. The correct answer is C. Post-precipitation involves washing the precipitate to remove any soluble impurities and improve its purity in gravimetric analysis. Which of the following is not a common factor affecting the quality and purity of a precipitate in gravimetric analysis? A. Temperature. B. pH. C. Particle size. D. Analyte concentration. The correct answer is D. While analyte concentration can affect the sensitivity of the analysis, it is not a factor that directly influences the quality and purity of the precipitate. What is the purpose of adding a precipitating agent to a sample solution during gravimetric analysis? A. To dissolve the analyte. B. To form a colored complex. C. To coagulate the precipitate. D. To precipitate the analyte. The correct answer is D. The precipitating agent is added to cause the analyte to form a solid precipitate, which can then be separated and weighed in gravimetric analysis. In gravimetric analysis, what is the term used to describe the process of removing excess reagent and soluble impurities from a precipitate to improve its purity? A. Filtration. B. Precipitation. C. Drying. D. Washing. The correct answer is D. Washing involves rinsing the precipitate with a suitable solvent to remove impurities and ensure its purity in gravimetric analysis. Which of the following statements about gravimetric analysis is true? A. It relies on volumetric measurements. B. It is less precise than titrimetric methods. C. It is based on the measurement of mass changes. D. It is only applicable to liquid samples. The correct answer is C. Gravimetric analysis is based on measuring the mass of a precipitate to determine the amount of analyte present in a sample, making it a technique focused on mass changes. Which of the following is a common method for estimating the purity of a precipitate in gravimetric analysis? A. Colorimetric titration. B. Conductivity measurement. C. Recrystallization. D. Volumetric analysis. The correct answer is C. Recrystallization is a common method used to estimate the purity of a precipitate in gravimetric analysis by promoting the growth of pure crystals. What is the purpose of using an inert atmosphere in gravimetric analysis processes? A. To prevent contamination from air moisture. B. To enhance the solubility of the precipitate. C. To accelerate the precipitation reaction. D. To improve the visibility of the precipitate. The correct answer is A. Using an inert atmosphere helps prevent contamination of the precipitate from moisture in the air, ensuring accurate results in gravimetric analysis. Which of the following factors may lead to a low yield in a gravimetric analysis procedure? A. Extending the drying time of the precipitate. B. Incomplete precipitation of the analyte. C. Using excessive reagents in the analysis. D. Conducting the analysis at a lower temperature. The correct answer is B. Incomplete precipitation of the analyte can lead to a low yield in gravimetric analysis by not capturing all of the analyte in the precipitate. Which of the following techniques can be used to determine the purity of a precipitate in gravimetric analysis without involving chemical reactions? A. Nuclear magnetic resonance, NMR. B. X-ray diffraction, XRD. C. Gas chromatography, GC. D. Ion exchange chromatography. The correct answer is B. X-ray diffraction, XRD, can be used to determine the purity of a precipitate by analyzing its crystal structure without involving chemical reactions. What is the term for the process of removing soluble impurities from a precipitate by repeatedly dissolving and reprecipitating the substance in gravimetric analysis? A. Crystallization. B. Leaching. C. Precipitation cycling. D. Decantation. The correct answer is C. Precipitation cycling involves dissolving the precipitate, separating soluble impurities and reprecipitating the substance to improve its purity in gravimetric analysis. How does co-precipitation contribute to the purity of a precipitate in gravimetric analysis? A. By increasing the mass of the precipitate. B. By forming a solid solution with the impurities. C. By adsorbing impurities onto the growing particles. D. By enhancing the filtration process. The correct answer is C. Co-precipitation helps improve the purity of a precipitate by adsorbing impurities onto the growing particles, leading to their removal during filtration in gravimetric analysis. Which of the following statements about post-precipitation in gravimetric analysis is true? A. Post-precipitation involves adding a reagent to dissolve the existing precipitate. B. Post-precipitation aims to increase the volume of the precipitate. C. Post-precipitation is performed before the primary precipitation step. D. Post-precipitation helps remove any remaining impurities from the precipitate. The correct answer is D. Post-precipitation in gravimetric analysis is used to further purify the precipitate by removing any remaining impurities through a secondary precipitation step. What role does the filtration process play in gravimetric analysis procedures? A. To convert the precipitate into a soluble form. B. To collect the solid precipitate from the solution. C. To accelerate the precipitation reaction. D. To measure the absorbance of the precipitate. The correct answer is B. Filtration is used to separate and collect the solid precipitate from the solution in gravimetric analysis after the precipitation reaction has occurred. Which of the following methods is commonly used for the precise determination of barium as barium sulfate in gravimetric analysis? A. Turbidimetry. B. Titration with EDTA. C. Atomic absorption spectroscopy. D. Precipitation using sulfates. The correct answer is D. Precipitation using sulfates is a common method for the precise determination of barium as barium sulfate in gravimetric analysis procedures. What is the role of co-precipitation in gravimetric analysis when determining the purity of a substance? A. It helps improve the purity of the precipitate by reducing impurities present alongside the analyte. B. It is used to remove excess reagents from the sample solution. C. It involves dissolving the precipitate to purify it further. D. It helps speed up the precipitation process. The correct answer is A. Co-precipitation is the addition of a second reagent to co-precipitate the analyte and improve the purity of the precipitate by reducing impurities. How can post-precipitation aid in determining the purity of a precipitate in gravimetric analysis? A. By dissolving the precipitate to increase impurities. B. By adding more analyte to the precipitate. C. By further purifying the precipitate through additional chemical actions. D. By lowering the precipitation time. The correct answer is C. Post-precipitation is a technique used to further purify the precipitate by performing additional chemical actions to increase purity. Why is it important to estimate the purity of a precipitate in gravimetric analysis? A. To speed up the analysis process. B. To ensure accurate results and minimize errors in determining analyte concentrations. C. To increase the yield of the procedure. D. To reduce the cost of reagents used. The correct answer is B. Estimating the purity of a precipitate is crucial to ensure accurate results and minimize errors in determining analyte concentrations in gravimetric analysis. What method is commonly used for estimating the purity of a precipitate in gravimetric analysis without involving chemical reactions? A. Spectrophotometry. B. Inductively coupled plasma mass spectrometry, ICP-MS. C. Weight analysis. D. Thermogravimetric analysis. The correct answer is C. Weight analysis is a common method for estimating the purity of a precipitate in gravimetric analysis without involving chemical reactions. What is the primary purpose of using an inert atmosphere in gravimetric analysis processes? A. To increase the solubility of the precipitate. B. To prevent the loss of analyte due to reactions with atmospheric gases. C. To accelerate the precipitation process. D. To reduce the temperature needed for precipitation. The correct answer is B. Using an inert atmosphere helps prevent the loss of analyte due to reactions with atmospheric gases, ensuring the accuracy of the gravimetric analysis. How do impurities affect the yield of a gravimetric analysis procedure? A. They increase the yield by adding more mass to the precipitate. B. They have no effect on the yield. C. They decrease the yield by interfering with the formation of pure precipitate. D. They speed up the precipitation process. The correct answer is C. Impurities can decrease the yield of a gravimetric analysis procedure by interfering with the formation of a pure precipitate, affecting the accuracy of the results. Which technique can be utilized to remove soluble impurities from a precipitate by dissolving and reprecipitating the substance in gravimetric analysis? A. Co-precipitation. B. Filtration. C. Weight analysis. D. Post-precipitation. The correct answer is D. Reprecipitation is the process of removing soluble impurities from a precipitate by dissolving and reprecipitating the substance, helping to improve the purity in gravimetric analysis. How does co-precipitation contribute to the purity of a precipitate in gravimetric analysis? A. It helps remove excess reagents from the sample solution. B. It improves the crystallinity of the precipitate. C. It decreases the yield of the analyte. D. It reduces impurities present alongside the analyte in the precipitate. The correct answer is D. Co-precipitation helps reduce impurities present alongside the analyte in the precipitate, thereby improving its purity in gravimetric analysis. Why is post-precipitation used in gravimetric analysis? A. To speed up the precipitation process. B. To decrease the purity of the precipitate. C. To further purify the precipitate and remove impurities. D. To increase the solubility of the precipitate. The correct answer is C. Post-precipitation is used in gravimetric analysis to further purify the precipitate by removing impurities and increasing its purity. What is the purpose of weight analysis in gravimetric analysis procedures? A. To estimate the volumetric ratio of the precipitate. B. To determine the mass of the analyte in the sample. C. To identify impurities in the precipitate. D. To calculate the density of the precipitate. The correct answer is B. Weight analysis is used to determine the mass of the analyte in the sample during gravimetric analysis procedures. What is the term for the process of heating a precipitate to a constant weight to determine its mass in gravimetric analysis? A. Precipitation. B. Decantation. C. Drying. D. Filtration. The correct answer is C. Drying refers to the process of heating a precipitate to a constant weight to calculate its mass accurately in gravimetric analysis. What does the term co-precipitation refer to in gravimetric analysis? A. Additional precipitation to increase yield. B. Simultaneous precipitation of analyte and impurities. C. Post-precipitation method. D. Precipitation in a controlled atmosphere. The correct answer is B. Co-precipitation involves the simultaneous precipitation of the analyte of interest and impurities to improve the purity of the precipitate in gravimetric analysis. How can post-precipitation assist in estimating the purity of a precipitate in gravimetric analysis? A. By increasing the size of the precipitate particles. B. By removing soluble impurities through dissolving and reprecipitating. C. By adding a second reagent to co-precipitate impurities. D. By measuring the turbidity of the solution. The correct answer is B. Post-precipitation aids in estimating the purity of a precipitate by removing soluble impurities through dissolving and reprecipitating the substance in gravimetric analysis. What is the primary purpose of weight analysis in gravimetric analysis procedures? A. To determine the solubility of the precipitate. B. To calculate the molarity of the solution. C. To measure the mass of the precipitate accurately. D. To identify impurities in the sample. The correct answer is C. The main goal of weight analysis in gravimetric analysis is to accurately measure the mass of the precipitate formed, which is crucial for determining the purity of the substance in the sample. Which of the following methods is commonly employed for the precise determination of barium as barium sulfate in gravimetric analysis? A. Titration. B. Spectrophotometry. C. Complexometric titration. D. Gravimetry. The correct answer is D. Gravimetry is commonly used for the precise determination of barium as barium sulfate in gravimetric analysis. What is the term for the process of determining the percentage purity of a precipitate in gravimetric analysis without involving chemical reactions? A. Volumetric analysis. B. Thermogravimetric analysis. C. Conductometric analysis. D. Ignition test. The correct answer is B. The term for the process of determining the purity of a precipitate without involving chemical reactions is thermogravimetric analysis. How does co-precipitation contribute to enhancing the purity of a precipitate in gravimetric analysis? A. It reduces the yield of the precipitate. B. It helps in increasing the solubility of the impurities. C. It aids in co-precipitating impurities with the analyte. D. It accelerates the filtration process. The correct answer is C. Co-precipitation involves the addition of a second reagent to co-precipitate impurities with the analyte, thus enhancing the purity of the precipitate. What is the role of post-precipitation in gravimetric analysis when determining the purity of a precipitate? A. To reduce the analyte content in the precipitate. B. To enhance the crystallinity of the precipitate. C. To further purify the precipitate by eliminating soluble impurities. D. To increase the yield of the precipitate. The correct answer is C. Post-precipitation is used to further purify the precipitate by removing soluble impurities and improving its purity in gravimetric analysis. Why is it essential to estimate the purity of a precipitate in gravimetric analysis procedures? A. To determine the exact mass of the precipitate. B. To calculate the solubility of the precipitate. C. To ensure accurate results in the analysis. D. To speed up the precipitation process. The correct answer is C. Estimating the purity of a precipitate is crucial to ensure the accuracy and reliability of the results obtained in gravimetric analysis. What is the ultimate goal of weight analysis in gravimetric analysis procedures? A. To determine the volume of the precipitate. B. To calculate the density of the precipitate. C. To measure the mass of the precipitate accurately. D. To identify the color of the precipitate. The correct answer is C. The ultimate goal of weight analysis is to measure the mass of the precipitate accurately in gravimetric analysis procedures.